limit as x goes to a, not 0, x goes to a, f of x minus f of a, all over x minus a. So limit x goes to a. F of x is just square root of x plus 6. F of a would be the square root of a plus 6, correct?
Yeah.
All over x minus a. How do I do that? I have to use a conjugate. Correct? We just did these limits. X plus 6 plus square root of a plus 6, top and bottom. So the limit, x goes to a. Now when I multiply the first two, I get
X plus 6.
x plus 6. Now the inside two, minus square root times square root plus square root times square root, correct?
Wait, what?
They cancel out, which is what should happen. So the last two, be careful here. Minus a plus 6 in parentheses, correct? Because when you multiply this and this, you get a plus 6, but it's subtracting all of that. That's where people mess up. Now remember, on the side that you did not use a conjugate, leave it factored. If you get stuck, multiply it out, but otherwise leave it factored. So limit x goes to a, x plus 6 minus a minus 6 all over x minus a.
Wait,
It's distributed.
are we allowed to cancel out, like?
Absolutely not.
Okay.
I don't know where you were going with that, but no. Nothing cancels. Yet. Now they do. But the step above, no, they do not. Not until you distribute can you dare try to cancel those. Correct? So now the 6's cancel. Left with limit, x goes to a, x minus a all over, x minus a, square root of x plus 6, plus square root of a plus 6. Now what? The x minus a is canceled here because it's factored out, correct? So cancel, cancel. I have the limit, x goes to a, 1 over square root of x plus 6, square root of a plus 6. Here's where it gets confusing. Okay. If I had the limit as x goes to 2, you would plug 2 in for x, correct?
Yeah.
So here I'm going to plug a in for x. Yes? So when I do that, I'm going to be left with 1 over 2 square root of a plus 6. Yeah? And since this is a function, we're not going to clean that up. But that is my f. Actually, that's f prime of a, correct? Yes? Because it's in terms of a. My variable is just a in this case. You follow that logic? Instead of f prime of x, I used a. As long as we're clear, I could easily call that f prime of x 1 over 2 square root of x plus 6. You see it's the same thing, I just changed the variable, right?
Yeah.
But didn't it ask for me to find at x equals 3? Here's why it confuses people, because they're ended with a. They're like, wait a minute, how is x 3 if I have a? Just a variable, correct? You can easily change that variable. So I'm just going to plug in f prime of 3. It's 1 over 2 square root of 9, which is 1 over 6. Questions? Let me show you an alternative way of doing this problem. Limit, I could say right away that a is its second point, correct? Look at my graph. X and a are just 2 different points, right? Well, if I want to know as I go to 3, I could plug in 3 right away. So I could have done limit as x goes to 3, f of x minus f of 3, x minus 3. I could have actually just plugged in for my a. Then I would have had limit x goes to 3, square root of x plus 6 minus square root of 9, right, when I plugged it in? Which would have been limit x goes to 3, square root of x plus 6 minus 3, all over x minus 3. And then I would have done my conjugate and still have gotten there. That, a benefit to that is it's actually nicer, it's shorter, cleaner. What's a negative of that? You only found it at 3, so if the next question said find the derivative at 4, you're doing the whole problem over again, correct?
Yeah, it's the same thing like the last chapter when like the book did it one way and you want.
Exactly. I mean, you can do either way. It depends on what's being asked. So this is great because it does make my calculation shorter, and I don't have to plug in the end because it's already plugged in. However, if they go ahead and ask, well, what's the derivative at 2, you do that whole problem again. Which is fine. If it only asks for one spot, you can do this. Does that make sense?
Yeah.
They mean the exact same thing.